In this section, we will talk about quadratic functions, but using business applications. Let's say you own and operate a small t-shirt printing business. The cost is the cost that you incur. This usually includes some kind of fixed cost, like your rent, your utilities, salaries, those are usually fixed. And the variable cost, because for every t-shirt that you print, you have to buy the material, things like that. You got to, pay for the ink. So every extra t-shirt you print has some kind of variable cost, and the variable cost changes, whereas the fixed cost is going to remain fixed each month. Here's an example. Your daily fixed costs are $150. This once again includes like your rent, which is fixed, utilities, salaries, things like that. And each t-shirt costs $1.25 to print. Write an equation for your daily cost C of X. So C is the cost of printing X shirts, and that equals to your fixed cost, which is 150. That cost is not going to change. So even if you close down for the day, even if nobody shows up, you still got to pay the rent, you still got to pay the utility. So that's going to be $150. And each t-shirt costs $1.25 to print. So for every t-shirt, it costs 125, which is why the variable cost is 1.25x. And there's a variable there since the more shirts you print, the more you have to pay for your cost. So that's going to be the cost equation. Now the revenue is the amount of money you make from selling X t-shirts. This is like your gross income. That's just how much money that comes in. And revenue is always going to be price times quantity. For example, let's say that a t-shirt costs $12, so that's going to be the price. And the quantity is how many shirts you sell. Let's say you sell just one shirt, then your revenue is going to be 12 times 1, or $12. But let's say that instead of selling one shirt, you sell each shirt for $12, but you sell 100 shirts, then your revenue is going to be 12 times 100, which is $1,200. Because for each shirt you sell, you're bringing in 12 bucks. So revenue is always given as price times quantity. So if you sell X number of t-shirts, your revenue is going to be the price times X, which is going to be your quantity. Okay, so if you sell a t-shirt for $12, what is the revenue function? So the revenue is going to be your price, which is 12, times X, which is the number of shirts that you sell. Now the profit is given by revenue minus cost. Revenue is how much money comes in, cost is how much money goes out. For example, let's say that you're printing 10 shirts. So your revenue, if you sell 10 shirts, is going to be 12 times 10. So 12 is how much each shirt costs. $10, $12 is how much each shirt costs. 10 is how many shirts you sell. So the revenue is going to be 120. That's just how much money comes in. Okay, but your cost is 150, so you got to pay that every single day for your rent and things like that, plus 1.25 times 10. Okay, and that comes out to be 162.50. So even though you made $120, you spent $162.50. So your profit is going to be your revenue. That's how much money came in, which is $120, minus your cost, which is $162.50, and that's going to give you negative $42.50 for your profit, which means you lost $42.50 if you only sold 10 shirts. So the profit is given by revenue minus cost. So in this case, the profit function is going to be your revenue function, which is 12x. And anytime you replace a variable with an expression, always use parentheses. So it's going to be parentheses 12x minus parentheses your cost, which is 150 minus 1.25x. Now remember that when you combine like terms, you have to first distribute the negative. So we get 12x minus 150 minus 1.25x. And then if you combine your like terms, your profit function is going to be 10.75x. That's 12 minus 1.25 minus 150. And for proper notation, I'm going to say this equals to P of x, which is the profit function. The break-even point is when revenue is going to equal to cost. So if you have $120 coming in, but you spent $162.50, you're losing money. So the break-even point is when the revenue and the cost are equal to each other. That means you don't lose money, but you're not making any money yet either. So in this case, how many shirts do you have to sell in order for the in order to break even. So when you break even, your revenue is going to equal to your cost. Your revenue is 12x. Your cost is 150 plus 1.25x. So when revenue and cost are equal, you break even. So I'm going to subtract 1.25x from each side. This gives you 10.75x equals to 150. Then you divide both sides by 10.75, and you end up with x equals to 13.95. But you can't sell 0.95 of a shirt, so we're going to round up to approximately 14 shirts. So if you sell about 14 shirts, you are going to break even. And I'm going to show you guys that. Okay, so let's find the revenue from selling 14 shirts. So the revenue is going to be $12, which is going to be the selling price of each shirt, and you sell 14 shirts. So every shirt sells for $12, and you sell 14 of those shirts. So your revenue, the amount of money coming in, is 12 times 14, or 168. Now your cost for selling 14 shirts, so your the number of shirts is 14, so that's going to be 150 plus 1.25 times 14. Okay, so we've got 1.25 times 14 plus 150, that's going to be 167.50. That's going to be your cost. Your profit is going to be your revenue minus your cost. So you're making a profit of about 50 cents. So that's about the break-even point. If you take your revenue, subtract the cost, you're making about 50 cents if you sell 14 shirts. Obviously, the more shirts you sell, the more profit you're going to make. So that's kind of the basic concept we're going to be revisiting throughout this section, that the cost is always going to be a fixed cost and a variable cost. So this cost is going to be your fixed cost, and this cost is going to be the variable cost. The revenue is always going to be the cost of the shirt times the number of shirts that you sell. The profit is going to be the revenue minus the cost. Okay? So here's an example. The parent company sells P phones. The cost to manufacture X P phones is given as this function right here. So this here is going to be your cost function. The revenue function is given to us as this. So the question is, how many P phones should the company sell in order to maximize the profit function? And what is the maximum profit? So first off, because we're referring to the profit, we need a profit function. So remember that. Anytime you're referring to the profit, you need a profit function. So our profit function is given to us as the revenue minus the cost. Okay, our revenue is, and again, make sure to always use parentheses, is negative 35x squared plus 194,000x minus the cost, which is given to us as negative 27x squared plus 50,000x plus 21,737. Okay, so that's your revenue minus your cost. Anytime there's a negative in front of an expression, that has to distribute. So we have negative 35x squared plus 194,000x. The negative is going to distribute. So we have a negative times a negative, that's a positive 27x squared. A negative times a positive, that's a negative 50,000x. And a negative times a positive, that's a negative 21,737. Now, if you combine your like terms, you have negative 35 and positive 7. That's a negative 8x squared. You got 194,000 minus 50,000, and that gives us a positive 144,000x. And then finally, you got the negative 21,737. That does not have any like terms. So this is going to be your profit function. Now, notice that your profit function is a quadratic, and the quadratic has a coefficient of negative 8. Okay, so here's what it means. Every quadratic is going to be in the shape of a parabola, but if the a is negative, that means the parabola is going to open towards negative infinity. So it's going to look like this, and this will be your vertex. Now, anytime you are asked to find either the maximum or the minimum of a quadratic, that's always going to happen at the vertex. And if you recall, the vertex is given by x equals to negative b over 2a. So when you're dealing with quadratics, anytime you're asked for the maximum or the minimum, that's going to be the highest or lowest point, which is always going to be the vertex. And the vertex is given by x equals to negative b over 2a. Okay, so x is equal to negative b, which is negative 144,000, divided by 2 times a, which is 2 times negative 8. You can put this in a calculator, and you'll get that this equals to 9,000. X represents the number of units sold, the number of phones sold. So we have to sell 9,000 phones in order to maximize your profit. Okay, now, what is a maximum profit? So X represents a quantity. Okay, X represents a quantity. And P of X, this represents the actual profit. So we're going to say that P of 9,000, so the profit for selling 9,000 phones, is equal to negative 8 times 9,000 squared plus 144,000 times 9,000 minus 21,737. Okay, and that equals to 647,978,000 and 263. So the profit is revenue minus cost. The maximum always occurs at the vertex, which is the formula negative b over 2a. That's your negative b. 2 times a is 2 times negative 8. When you get that, that gives you your quantity. So your quantity is going to be that you have to sell 9,000 phones to maximize profit. And the maximum profit is given to us here by plugging in the quantity to the profit function. This example we will do in class, but it's very similar to the last one. The only difference is we have to find the cost function ourselves. Okay, here's the last example. It says that the price demand function P of X is a price that a company can charge when they produce X units. Okay, now that basically means that the more something is available, the cheaper it becomes. So the price of something depends on how many of those there are, how many units there are in the world. For example, when toilet paper became scarce, the price of toilet paper shot up, right? So the more in demand something is, the lower its price. So price and quantity are related. And the revenue is given as the price times the quantity. So this is something you definitely have to know. Revenue is given as the price demand function, which is the price times the quantity. Okay, so the question here says the unit cost to produce tubs of ice cream is $9 and the fixed cost is $76.88. The price demand function is P of X equals to 319 minus 2X. So first, let's find the cost function. So our cost function C of X is going to be your fixed price, which is 76.88, plus your variable cost, which is 9X. So each tub costs $9, so your fixed cost is 76.88, and your variable cost is going to be 9X. So this is going to be the cost function. The revenue function is given as the price times quantity, but this time price is given to us as 319 minus 2X. And then we still have the times X. So your revenue is going to be given as 319 times X, which is 319X, and negative 2X times X, which is negative 2X squared. So this is going to be your revenue function. And then it says find the profit function. So profit P of X, that equals to the revenue minus the cost. The revenue is 319X minus 2X squared, minus the cost is 76.88 plus 9X. So here you would distribute the negative, and then you would combine like terms. And if you distribute the negative and you combine like terms, you're going to end up with a negative 2x squared, negative 2x squared plus 310x minus 76.88. And that's going to be your profit function.